Having trouble writing expressions for sequences? Watch this video for some help. Okay, here we have a sequence 2, 4, 6, 8, 10, 12, and I've got those numbers labeled on the number line here up to 20, but these numbers continue on. So you can see this is counting by twos, so I know that this is a 2 times n sequence because every time the term number increases, then the numbers are going up by twos. So this is very easy to identify as 2n. But what if I take this sequence, if I take all these numbers and just shift them over to the right one? Now we have a different sequence. We have the sequence 3, 5, 7, 9, 11, 13, and so on. So these are still counting by twos. So this is still a 2 times n sequence, but we've shifted everything up. Every number got shifted up 1. The 2 got shifted up to 3, the 4 got shifted up to 5, the 6 got shifted up to 7, and so on. So this is a 2n sequence, but all we did was add 1 to each number. So now they're all 1 bigger. So we would say the expression for this sequence is 2 times n plus 1, 2n plus 1. So again, what if I were to take this sequence and move it here? Now the sequence starts at 0 instead of starting at 2. So now my sequence is 0, 2, 4, 6, 8, 10. Still counting by twos. So this is still a 2n sequence, but now instead of starting at 2, it's starting at 0. So I've shifted it down, and so this is 2n minus 2 because all of the numbers are 2 less than the 2n sequence. 0 is 2 less than 2, 2 is 2 less than 4, 4 is 2 less than 6, and so on and so forth. So again, I can take this same sequence, and no matter where I drop it, it's always going to be a 2n sequence because they're always going to be counting by twos. Every number is going to be 2 numbers apart, no matter where I move it on the number line. So for example, if I drop it here, I have the sequence 7, 9, 11, 13, 15, and so on. This is still a 2n sequence, but now it is shifted. Normally it starts at 2, but it got shifted 1, 2, 3, 4, 5 places to the right. Now it starts at 7 instead of starting at 2. So this is a 2n plus 5 sequence. So that's our expression for this sequence. 2n, because it's counting by twos, plus 5 because we have shifted it 5 places to the right. Let's take a look at this one. Here's the 3n sequence. This one's counting by threes. 3, 6, 9, 12, 15, 18, 21, and so on. So again, any sequence where the numbers are 3 numbers apart is going to be a 3 times n sequence. But now I can move this to different places on the number line. So for example, if I move everything to the left one here, now I have the sequence 2, 5, 8, 11, 14, 17, and so on. So again, these are still 3 numbers apart. They're counting by threes. So this is a 3n sequence, but now all the numbers got shifted 1 to the left. They're all 1 less than they were before. So this is 3n minus 1. And again, if I were to take it and drop it 1 more place down here, I create a new sequence that still counts by threes, but it's 1, 4, 7, 10, 13, and so on. So again, this is a 3n sequence, but all the numbers are 2 less than what they started with because this sequence normally starts at 3, but it got shifted 2 places to the left. So this would be 3n minus 2. So again, one more example here. If I take this and let's really move it. So if I put this here, so normally again, this sequence, this 3n sequence starts at 3, but now it is 10, 13, 16, 19. Notice these are all still 3 numbers apart. So this is a 3n sequence, but instead of starting at 3, we have shifted it up 1, 2, 3, 4, 5, 6, 7 places. So this is a 3n plus 7 sequence. And that's basically all there is to figuring out what the expression is for any arithmetic sequence, is figure out what are you counting by and is it shifted up or shifted down from what it started at. So again, here's the 4n sequence, same stuff. All of these numbers are 4 numbers apart. So the 4n sequence goes 4, 8, 12, 16, 20, 24, and so on. But again, if we were to take this and shift it around, so if I move these numbers up a couple places, now I have a new sequence of 6, 10, 14, 18, and so on. Again, these numbers are all 4 apart, 6, 10, 14, 18. Those are all 4 numbers apart. So this is a 4n sequence, but it's shifted because normally this sequence starts at 4, but it got shifted up 2 places. So this is 4n plus 2. Now, if I were to take it again, and if I move these dots down here, and my sequence starts, let's not do that. Let's have my sequence start here at 1. So I have 1, 5, 9, 13, 17, and so on. Again, this is a 4n sequence because these numbers still count by 4s. They're all 4 apart, but normally it starts at 4, but this was shifted 3 places to the left. So this would be a 4n minus 3 sequence. See, so again, what is it counting by? That tells you what kind of sequence it is. And then is it shifted from its natural position? So let's try these sequences out here. I don't have a number line to help us, but we can figure these out. So 2, 7, 12, 17, 22. What kind of sequence is this? Basically, what are we counting by? So as this sequence progresses, we are counting by 5s. So I know that this is a 5n sequence. So 5n sequence starts with 5. Every type of sequence starts with its own number. So 5n sequence starts with 5. So it'd be 5, 10, 15, 20, 25, 30. So is this the 5n sequence that goes 5, 10, 15, 20, 25? No, these numbers are all smaller. So this one was shifted down. So this was shifted down 3 places. So we took 3 away from each one of those numbers in the 5n sequence. So what's my expression? 5n minus 3. So for any term in that sequence, 5 times n minus 3 is going to give me what the term is in that sequence. Next one, negative 2, 2, 6, 10, 14, 18. So what are we counting by here? Every time we move up in this sequence, we are increasing 4. So this is a 4n sequence, and it is not the 4n sequence because the 4n sequence starts with 4, 8, 12, 16, 20, 24, and so on. So these numbers are all less than the 4n sequence. So this got shifted down. So again, imagine taking those dots and shifting them to the left on the number line. How far left did they go? Well, these numbers are all 6 less than the 4n sequence. So my expression is 4n minus 6. Next one, 13, 25, 37, 49. What type of sequence is this? Again, as we go, we are counting by 12s. This is actually a 12n sequence. And the 12n sequence that counts by 12s is 12, 24, 36, 48, and so on. And all of these numbers are just shifted to the right. They're all 1 bigger than the 12n sequence. So that got shifted up 1. So my expression is 12n plus 1. And then this last one, we are counting by 7s. So this is a 7n sequence. And is it shifted up? The 7n sequence starts with 7, 14, 21, 28, 35. Well, that's done. So it's not shifted at all. So the expression for this is 7 times n. So there you have it. Hopefully this helped you figure out how to start building expressions for arithmetic sequences.